Hello everyone, it's Miawan, and today we're doing the 20th Cyprus Mathematical Olympiad that happened in 2019. We're going to be covering that one, and this is the 5th and 6th grade level. So I advise this video for anybody who wants to learn more, get a feel for the paper, or might as well check if you've already done it, or just learn something new and have fun. So anyways, let us continue. So first I have to go over the rules, because if for anybody who wants to know that, they can listen to this or they can just directly skip to the questions part. So in case you want to do that, you can just skip a few minutes. So let's just see this. So it says here, examples of filling the answer sheet. Now you'll get this paper, which I'm covering right here, right now, and there'll be like at least 5 options. And now the thing is, you'll have to have another sheet. You're going to have another sheet, and it has the options: alpha, beta, gamma, delta, eta, the 5 first Greek letters in the alphabet, in the Greek alphabet. And now basically you're going to have to shade in the correct answers. So here's examples of the correct filling. You could shade in this answer, you could shade in this answer, or you could shade in none if you have no idea. But the thing about these are, there are no multiple answers normally. Now incorrect fillings is that you only have to shade. There is not any 2 option answers. You can't just circle it not neatly like this, and you can't just cross it to show that it's the answer, because that basically means that you're saying it's wrong. Like for example, if you realize that delta is wrong and you want to circle beta, you'll have to do it neatly, but I'm just rushing it a bit right now. Yeah, so basically you get the idea. You shade in the option that you like and then that you think it's correct, and then you cross out the option that you said was wrong. My writing would be a bit dirty since I'm working here on OneNote, so I apologize for that. But furthermore, let us continue. Oh wow, what is happening? Okay. Oh yeah, 1 minute. There we are. So now we're just going to cover the questions. So first, what is the value of the expression 33 plus 44 plus 55 plus 66 divided by 11? Now if you look at these numbers, 33 is 3 times 11, 44 is 4 times 11, 55 is 5 times 11, 66 is 6 times 11. And since we're dividing by 11, you can cancel with all of these. So you'll be left with 3 plus 4 plus 5 plus 6. You do 3 plus 4 plus 5 plus 6, and you get 18. So we can say that alpha here is the answer. Or if you want to, you can just you can just add them and divide by 11. But if you're dividing by 11 or multiplying by 11, I can just cover a really nice trick here. So let's just say you're doing 11 times 12. We all know that's 132. But if you look closely, the first digit of the number you're multiplying with 11 is here. The second digit is at the end of the product. And the sum of these 2 numbers is 3. It is there. It's in the middle. This works for any product that's a 3-digit number. And you can even check this with 11 times 11. So you can say 112, 121. You can check it on your calculator if you want. It's the same with 11 times 72 even. 792. 7 goes here, 2 goes here. 7 plus 2, 9. And if you have like a bigger number like 11 times 89, the 8 goes here and the 9 goes here. But wait, 8 plus 9 is 17, and you can't fit a 2-digit number to 1 digit. So you carry over that extra 1 here, and then it becomes 979. Really simple, right? Okay, so now that we know that, you can use that, and then when you're dividing, you can just look at the first 2 numbers here for every 3-digit number, and then you can find out the answer just like that if you're dividing by 11. That would be helpful in some other questions that are going to come up in this paper too. Now, the students of a class were asked about their favorite lesson. The results are represented in the bar chart below. How many are the students of the class? So first thing we have to do, we look at the bar chart and we look at the values. So the English has 6 students. 6 students saying that English is their favorite. Mathematics, 16 students. And for music, we have 10 students. And for Greek, it's surprisingly in the middle of 2 and 4. So in the middle of here. So in the middle of 2 and 4, we can say that's free because it's definitely halfway. So we can say that's free. Now we add them together to find the number of students, because this bar chart represents all the sum of all of the bar charts is equal to the number of students in the class. So we're saying 16 plus 10 plus 6 plus 3, and you get 35. So therefore E is your option, epsilon. So how many different ways are there to arrange 3 different books in a row in my library? This is where factorials come in, but first we're going to talk about the normal, more widely used method. So let's say the books are 1, 2, and 3. This is one option. You can put 1 here, 2 here, and 3 here. We're just going to name the books numbers. Now we can keep the 1 here, but we can swap the 2 and 3. So it becomes 3 and 2. Then we can get the 2 here, 1 free, 2 free, 1. And it goes on like that. Now if you realize, after we've done this method for the 3-digit numbers, you realize that there are no others. These are all of them, and it's 6. So we can therefore say it's 6. This same works for 4-digit numbers. If we said 1, 2, 3, 4, we can just keep the 2, and then we do 1, 2, 4, 3. Then we go 1, 3, 2, 4, 1, 3, 4, 2, and so on. And there are more numbers for the more digits there are. But the easier way is that after this method are the factorials, basically. Now, if you look at what a factorial is, let's say we're saying 5 factorial. Basically, you have to look at the number and then you start with that. 5 times 4 times 3 times 2 times 1. Basically, the number there, which is 5, multiplied by all the numbers below it, is 5 factorial. So we know that's 120 once you do that all. So we know 5 factorial is equal to 120. Even if we look at the question below, it's 15 times 14 times 13 all the way to 1. That's 15 factorial. So that means that's also a factorial too. It's helpful nowadays. Now, in these questions. But it's also helpful in maths too, definitely. So, now since it says 3 different books in a row, the trick is when you're doing the arrangement, let's say n is the amount of book objects you're arranging. N factorial is the amount of arrangements that can happen, where n is a variable and the amount of objects there are. And I put n because it's a variable, and now we don't know the exact value. So this goes for all of them. Let's say here it's 3 different books. So we replace that with 3 factorial. 3 times 2 times 1 is 6, which means that the answer is 6. There's 6 different arrangements. It's as easy as that. So we can therefore say that delta is 6. But I don't recommend doing this if there are really high numbers, unless you memorize the factorials, which is a very good thing to do, because then you know directly. If you see 6 factorial, you directly know that's 720. Things like that. Anyways, Now, remember we said this is 15 factorial. There's a special rule for factorials here. Now, first, here's a question which will help with this. Okay, so look at 4 factorial, and then look at all the factorials below it, which is easy. You can multiply and get the values. Now look at the values. And then look at all the values of the factorials after 4. Do you notice any difference? Now the thing is, 1 factorial, 2 factorial, and 3 factorial, and including 4 factorial, these are the only factorials which don't have a 0 to the end of them. Because once we have 4 factorial, because since 5 factorial is 120, 720, you see, like, since we're multiplying by 5 and we got an even number so far, we get 0, which means that, and since we know that anything multiplied by 0 is 0, that means that it will always end in 0 in the end. So that means if any factorial is over 4 factorial, then it ends in a 0. Here it's 15 factorial, it's definitely over 4 factorial, so we can say that the answer is A, 0. So that's some good logic we can use there. And well done if you found out and noticed this when you paused the video and checked. Yeah, because you can pause the video and check it out, and you can understand for yourself. If you know that, that's a really good thing already, if you know that already. Now, the number in each rectangle represents its area. What is the value of number x? Now the thing is, this is actually supposed to be a square here, but the thing is, now you can't just directly look at the figures and say that's that. Normally the figures are not as accurate as you think they would be, and that's why you should never trust the figure. Just go with the values, because you don't know. But here you can only like solve it with a square to get like not that much of a complicated answer. If I'm wrong, I don't exactly know, but if I'm wrong, you can tell me. If I'm wrong for any of these things, you can tell me, but I'm pretty sure that this is the option. So yeah, 2, 2, 2. We can say this is 2, and since this rectangle, the small rectangle here, is also sharing the side of 2, 2 divided by 2 is 1. So we know the width or the breadth of the rectangle with x area is 1. It's 1. So now we look at this. They're both sharing the side 2, so that means this is 2.5, since 2.5 times 2 is 5. And then we can multiply 2.5 and 1 together since we got all the sides, and we get 2.5. So that's alpha. It's as simple as that. You just have to use simple geometry, since we know that the area of a square is side by side. Like if the side is a, it's a times a, which is basically a squared. So you square the side. And for a rectangle, the area is basically the length times the breadth. So it's as simple as that. Okay, so if alpha plus beta is equal to 6, then what is the value of the expression 12 plus 3 times alpha plus 5 plus 3 times beta? Now the thing is, you don't have to do any substitution with variables and all that. You don't have to say like alpha is 6 minus beta and beta is 6 minus alpha. You don't have to make everything harder. All you have to do is basically just find two positive numbers that add up to 6. So we're saying like 12, let's say 12 plus 3 times 4 plus 5 plus 3 times 2. So you get 12 plus 12 plus 5 plus 6. That is 35. And it actually works for other values too. Like if you said 12 plus 3 times 3 plus 5 plus 3 times 3, you get 12 plus 9 plus 5 plus 9. And that's also 35 if you add it up. So basically, the thing is, since you're following the rules, since you're always saying alpha plus beta is equal to 6, you'll always get the same answer in this case. And that means that you're always going to get 35. It's going to be correct because you're following the rules here. But it's not always like that. There can be certain set of rules more, like if the equation is different in a way, or there's another more rules. But this is the simplest of the simplest, so it's easy, this one. So we can say that it's Vita 35. Now, assuming that the pattern below continues, how many squares will be in the 20th figure? So the way we can do this is by finding a formula, which is basically normally an equation with a variable, a random value that we don't know. We just substitute a letter into that. And we use that equation as like, okay, here are the equations. They're normally what these are. The order. So let's say if it's first x is 1, second x is 2, third x is 3, and so on, etc. So basically with this, but first we have to find the pattern. So 1, 5, 9, 4, and then it's 13. That's a number of squares in each pattern. There's 1 square, 5 squares, 9 squares, and 13 squares. Now if you notice, they just keep adding on by 4, like 4 squares go on the one side, and we can see that. But that doesn't exactly help us, because if you want to go the long way, you could just do 4 and 4 again, but the trick is by using formulas. So first, if we go 1 square, that means that x is 1 here. So we can say 4 minus 3, 3 minus 2. In other words, we can just add an x there because x is 1, and anything times 1 is always itself. So that means that if we take 4x minus 3, because 4x minus 3 is the correct formula, but it takes some trial and error. You have to think about it exactly. So now it also works with the second, third, and fourth, because if we substitute, okay, so I'm going to go here. X is 2, x is 3, x is 4, which means 4 times 2, 4 times 3, 4 times 4, multiplied by, wait, actually I don't need to put brackets because of BODMAS. And then we have minus 3, minus 3, minus 3. So if we're following BODMAS, first we do the multiplication. The multiplication sign is the dot here. The dot was invented because since we have the x variable, which is most commonly used, and then the multiplication sign, they're almost the same, so you can get confused. So they use the dot, or normally they just stick the variable, whatever it is, together. If it's a variable and a number, they just stick them together without anything, and then only symbolize the multiplication. So that's why it's a dot and not a cross. So anyways, we have 8 minus 3, 12 minus 3, 16 minus 3. Because we always have multiplication first according to BODMAS here. So, or you could say BIDMAS, either way. Here it's here the O is operators, and in BIDMAS I is indices. So multiplication, then subtraction. So we have 5, 9, and 13. And if you check here, it's also 5, 9, and 13. So we know that it's correct with all the information given to us. But now it says how many squares will be in a 20th pattern, which means x is 20. 4 times 20 is 80, and 18 minus 3 is 77, which means the answer is option delta 77. Okay, so far, I'm just going to give a reminder. Please like and subscribe, ring that bell and a notification for more videos. So ring that bell to get notifications for more videos. You can subscribe, like the video for more of these videos, but we haven't ended yet, so let's continue on this journey. And please subscribe also for more videos like this. I really love making them, and I really hope you enjoy them as well. So now we have question number 8. The product of a number a and its double is 72, which is the half of number a. Now, basically it's saying that this x times 2x is equal to 72. Basically, 2x squared is equal to 72. So you can divide 72 by 2, 36. So we know x squared is 36. The root of 36 is 6, which means x is 6. And that means 6 times 12 is 72. Which is obvious when you think about it. Or if you know the tables, it's just a simple multiplication, so it can just pop in your head. Either way. But so that means a is 6. We can just replace that x with a here. So yes, that's basically what it is. So now it's saying what is the half of number a? So basically 6 divided by 2, half of 6. It's 3. So that means option alpha is the answer. Now, a housekeeper bought a piece of cloth and paid €62.50. If she had bought 3 more meters of cloth, she would have paid €100. How many meters of cloth did she buy? Okay, so now, basically, since we have €62.50 and €100, 100 minus 62.5 is basically 37.5. We can just take away the 0 for now, so that means €37.50, because this, if you see here, this is the price of the whatever meters of cloth the housekeeper buy plus 3 more meters, and this is the price of the meters of cloth that she actually bought. So 37.5 would be the 3 meter difference. So now, so basically, if we divide this by 3, €37.50. We get €12.50, which means 1 meter is €12.50. Now, since we know that, what we can do is that we can see how it's divisible by €62.50. So €62.50 divided by €12.50 is equal to 5. So basically that means the housekeeper bought 5 meters of cloth, meaning that gamma is the answer. Okay, just for a quick review of that method. €100 is the price of the meters of cloth the housekeeper bought plus 3 meters more. So minus €62.50. So this is €100 and this is €62.50 to get €37.50. €62.50 is the price of the amount of meters that the housekeeper actually got. So if you minus them, you get the price of 3 meters. You divide by 3 because we have 3 meters to find the price of 1 meter, and then you divide that by €62.50 itself, so you can get how many meters there are. It's 5 in this case. Now, question number 10. What is the value of digit z? We can obviously say that's 44. The digit is 4, because 44 plus 44 is 88. And 88 plus 12, because 4 times 3 is 12, is 100. You can check that since 8 plus 1 is that 9, so you know this is 90, this is 10, 90 plus 10, 100. So we know that it's 4 there, so that's E, 4. Now, this one is, you have to really think clearly. It says it's known that 1 upon 11 plus 1 upon 22 plus 1 upon 44 plus 1 upon 88 is equal to 15 upon 88. So what is the value of the sum 12 upon 11 plus 23 upon 22 plus 45 upon 44 plus 89 upon 88? If you noticed, all of these are improper fractions, which means the denominator, the lower number, is smaller than the numerator, the bigger number, which is how it shouldn't be. If you make them to mixed numbers, which is basically like a whole number and a fraction together, get 1 plus 1 upon 11, 1 plus 1 upon 22, 1 plus 1 upon 1 upon 44, plus 1 upon 88. The thing about these is that if you to simplify it, you can say 4 plus all of these fractions. So 4 plus 1 upon 11 plus 1 upon 22 plus 1 upon 44 plus 1 upon 88. You might have already worked out what I'm going to do now, because this section is the exact same thing here. It gives us the answer 15.88. So if we add 4 plus 15.88, it's obviously there's going to be no change. You just merge them together to get 415 upon 88, which means A is 415 upon 88.